Hello and welcome to another one of my tech videos. This time it's a project video and it's about building a weather station using one of these, a Raspberry Pi. Now my interest in weather stations goes back a number of years and I've had a couple of weather stations in the past, but these have been proprietary Oregon Scientific weather stations, cost about £100, and there's no way you can get the data off these things. And if I can't get them off, I can't get the data manipulated and uploaded to services like Weather Underground and Open Weather Map. Now the difference about this project is I will be using AWS's IoT service to get the data off these Raspberry Pi and into the cloud. And also I'll be using solar power because where I'm going to put this, although it will be in a weatherproof box, there was no mains power. So it all has to be done with batteries and solar panels. One thing I'd like to say before I start, however, is that I'm not an electronic expert. So these videos should be taken as entertainment only and the chance to laugh and point at somebody like me doing something really stupid. So just keep that in mind. So the remainder of this video will be part one of a multi-part series, and this one will go into starting off with the Raspberry Pi, powering it with power bank, and also doing some investigation into solar panels and how to charge the power banks. So if you enjoy that sort of thing, please watch on. Okay, so let's get started. Let's see if the Raspberry Pi can boot directly from a standard power bank. The Raspberry Pi I'm using is a stock Raspberry Pi. It does have a little plastic case and it does have a little USB wireless adapter. I don't know whether I'm going to connect it to the internet via this or via something like a 4G connection. That is up for discussion. But other than that, it's stock. It's a Raspberry Pi 2 Model B with a version 1.1 revision motherboard. And moving on to that, I need a good quality power bank to power it. And the one I'm choosing must have good control electronics because it'll need that when I'm using it for the solar panel later on. And the one I'm using is a Orkey 20,000 milliamp hour. It cost about £30 to £40 a couple of years ago. It doesn't matter if it's not this one, it can be anything, but it has to be good quality, not something you get from Poundland. And from then on, the only other thing I need is some sort of method to test it. I'm going to use this USB tester. And that'll show me the voltage output from the power bank, the current draw of the Raspberry Pi, and to see if everything meets the requirements of current and voltage. In this case, it's pushing out a good 5.04 volts, so that's pretty good. Exactly what it says it's going to put out. Incidentally, it does say it's going to put out 5 volts and 3.1 amps maximum, and that's good start. So let's get the boot up underway. Firstly, we'll put the HDMI cable into the Raspberry Pi and plug that into the monitor so we can see what is happening on the screen. And then it's the USB from the power bank to the Raspberry Pi. So let's get that plugged in. And what we should see is a nice consistent red power light on the Raspberry Pi. And the green light is the boot up process. It's the accessing of the SD card through the boot up process. So we should see that flickering on and off just like you would in the good old days of a hard drive booting up on a PC. Now we can see here that things are not good. The red power light is flashing on and off. The green light is flashing on and off, but it's clearly not got enough current to do the full boot up process. And for those eagle-eyed viewers on there, you'll see exactly what the problem is. The USB cable that I'm using to power from the power bank simply isn't good enough. It doesn't. It was a small, cheap USB cable, the only thing that I had my hands on when I was filming this, and it's clearly not up to standard. So I'm going to have to try something else. And with a bit of rearranging of my desktop and the procurement of a new high current USB cable, now we should be able to get this thing powered up. And this time I've got the USB tester in series, so I should be able to see what voltage and current draw we're getting out of this beast. So let's get it switched on. And with it switched on and the HDMI cable plugged in, which I haven't got it here, but you'll see that it will boot up entirely successfully, which is exactly what I wanted to see. And that means that the first bit of the test is complete. A successful Raspberry Pi boot up powered by the power bank. Now it's interesting to see here that the current draw is about 0.21 amps, and that's something that you need to remember for later on. The peak was about 0.37 upon boot up, and those values are something to remember. Don't worry, I'll remind you. There's no test later on when we start doing the work with the solar panels. Excellent, so it does appear that you can power a Raspberry Pi from a power bank, but in all honesty I kind of knew that. There's loads of videos all over YouTube showing you how to do it. What I don't know, however, is how to charge a power bank from a solar panel. So I bought a solar panel, and the next scenes that you will see was me out in my garden trying to test it out. So we've moved outside with the solar panel that I bought from Amazon and my little USB tester. And I want to take you through a little bit about the construction of this panel. Obviously, the links to it where I bought this will be in the comments section. But basically, as you can see on the screen, it's split into 4 sections of the photovoltaic material. And this is bonded between a transparent perspex layer and an opaque white perspex layer on the back. And if we turn it over, we'll see on the back that there is this little black device with a blue LED, and it's a voltage regulator. And the idea is that it takes the voltage from the solar panel and tries to keep it at a constant 5 volts output and a maximum of 2 amps. But as you can see from this video footage, my voltage regulator isn't doing that. It's cycling between on, off. So the blue LED comes on and goes off, and it's going between 5 volts, 0 volts, 5 volts, 0 volts. And that's no good to charge a power bank, which you need a constant current. And that was the whole purpose of this, of getting these solar panels. So at the stage I'm recording this video, I'm thinking I've got a dodgy solar panel or voltage regulator. And this is not a good situation to be in. That's not good. It appears I have a broken solar panel or voltage regulator or both. And what would any sane person do in this situation? Well, they'd send the solar panel back. It is of unmerchantable quality. It does not work. It ceases to function as a solar panel. What did I do? I bought another identical solar panel from a different vendor in a different country, this time via eBay. And I took it back out to the garden to test. Okay, we're back out in the garden again to test the new solar panel that I've just bought and the old one, just to make sure I'm not doing anything stupid, and to see if the fault still exists in the new purchase. And as you can probably see there, the voltage regulator lights, both of them are doing exactly the same thing. They're coming on and going off in a cycle. And again, at the point of me filming this video, I was despairing. So I guess the next step was just to corroborate this and to make sure that you can see what's actually happening here. You may not be able to see the LED coming on and off. So the voltage regulators do have a USB output on each of them, and I'm going to connect them up to a multimeter just to show you that it is indeed we're getting a 5 volt, 0 volt, 5 volt, 0 volt cycle. There you can see it's at 0 volts and 5.24 volts, as it apparently, and then back at 0 volts again, and that cycle will continue. And now let's try the other one. Plug it in the back. This is the new one, in fact, and 0 volts, 5.27 volts. So they're both the same. They're both doing exactly the same. So now I'm thinking that perhaps these solar panels are actually okay and there's something else wrong. So I thought I'd have one last go with both of the solar panels, and this time I'm actually literally going to point them outwards facing from the back garden and see, with maximum sunlight that we have in the northeast of England, which granted isn't great, but this is summer, so I should get something out of it. There is a bit cloud cover, you can see, but this is the best I can do, and this is what it will have to work under, the conditions it will have to work under anyway. So I'm just looking here at the voltage regulator on the back to see if it's going on and off, and it is. Again, I've got the little USB tester in, exactly the same as before. No matter where I position it, no matter how I direct the solar panel towards the sun, there's not enough to keep that voltage regulator on. And that's a very unhappy John. Okay, so it's easy to think from that last bit of footage that I've now got 2 broken solar panels, and you're all sitting there going, you are an idiot. And I thought that as well. I mean, I still think I'm an idiot, but not for this particular reason. You see, I've got 2 solar panels that are identical, but they were bought via eBay and Amazon from different vendors from different countries. The chances of them from the same batch are very slim, but they both exhibit the same behavior, the cycling of the 5 volt, 0 volt, 5 volt, 0 volt. So I'm thinking that that is actually what it's supposed to do. I did some more research on forums where people were actually using these solar panels in actual projects that were working. And turns out there's nothing wrong with these solar panels or the voltage regulators. If you live in Spain, Italy, Portugal, anywhere that the great fiery ball is on constantly. However, if you live in the northeast of England, it's not suitable. So what I'm going to do is take the voltage regulators off and try and find something better. So what happens next is that I spend an extraordinary large amount of time to take off these solar panels and partially damage the solar panels in the process. You're going to see this in a slightly speeded up form. I hope you enjoy the ineptitude. So what do I get after all of that time removing those voltage regulators? I get 2 solar panels linked together in series and time of my life that I will never get back. So I suppose the last bit of this video will be to test this out back in the garden in the sunlight to see what I actually get from these solar panels. Thank you for sticking with me on this one. This is the last bit of video. Enjoy. So here we are outside again to show you the lovely northeast England summer. The test this time will be to take the solar panels that are now in series with the voltage regulators removed and to do a duration test of an hour to see what voltage and current we get out during that hour. It's a nice summer's day with blue sky. You may see this is a little bit dull, and that's because the sun hasn't got around to this part of the garden yet. We will, to a certain extent, over the next hour when we do the test. And we will be testing, like I say, just the voltage and the current from without going through the voltage regulator. The test will be running, this test here will be running on the 1st of July 2018, or at least that's when I recorded it. And it'll be starting at about 6:45 in the morning and going for an hour. You'll receive other things that I'm putting on the flat surface, but the only thing you need to concentrate on is the solar panels and the multimeter. Anything else, there's a Raspberry Pi in the bottom right hand corner, and some other electronic components will be for future videos which I'm recording at the same time, so you get to see those in episode 2 or another episode, an interim episode perhaps. All you have to concentrate on here is the way that we set this up for the test. It's the solar panels in series connected to the multimeter set to voltage. Every so often, although I won't show you this on the video, I will actually switch the multimeter to amps and take off the current value, and I'll put that on screen when that happens. But for the next hour, condensed heavily because I've speeded it up, this will be the remainder of the tests for part 1 before we call it a day and get ready for episode 2. So you can see it rapidly increasing. We're in the 5.6 volts. And now 5.7. And this is just because the sun is starting to creep around and the clouds are starting to move. At about 5.75 volts, the current is 0.22 amps. Already we're up to 5.89, 5.87, 5.88, 5.89, and the current is at 0.28 amps. I think it's important at this point to cast your mind back to the start of this episode when we were testing whether the Raspberry Pi will power up from a power bank, and I did say to remember, although it wasn't a test that I would remind you, but the current that we're looking for, we're obviously looking for about 5 volts. We're looking for about 0.21 of amps to consistently give a good current reading to the Raspberry Pi and allow it to boot up and maintain that. And there was a 0.37 amp peak during that boot up phase. So with current values of 0.22 amps, peaking at like 0.28 amps, This is all in the good area for allowing the power bank to start charging during this period. So it's already in the 6 volts realm here. Wavering around 6 volts, the lower 6 volts, 6.06, 6.07 volts. Six point 6.12. You can actually see, if you look at the screen on the multimeter, where the clouds move and when the sun peeks through. Dropping down now a little, 5.8 volts. Hanging around 5.7 volts. Cloud is starting to come across and stopping the bright sunlight getting through. So this is just an ambient light. Around 5.6 volts now. We're definitely hitting a trough in terms of the voltage being generated by the photovoltaics. Still early in the morning, we haven't reached 8 o'clock yet. Around 8 o'clock I expect to see the clouds dissipate somewhat and we see a rise in voltage. Still around 5.6 volts, going up to 5.7 now. rising quite steadily now up to the upper areas of 5.8, going into 5.9 volts. Hovering around the 5.8, 5.9 volts. At this kind of voltage, I'd expect the current to be around 0.3 amps. If you remember earlier on, 0.37 was the peak when the Raspberry Pi was booting up, so we're certainly around that area. And remember, this is unregulated voltage. So we're after 8 o'clock now, and we're well after 8 o'clock now actually. About 20 past 8 in the morning. 20 past 8 in the morning. So the good thing about this is that we're seeing a consistent voltage. It does waver slightly, but we're between, we're where we want to be in terms of voltage. We're sort of the 5.5s up to peaking up to about 6.18, but certainly normally around a 5.6 to 5.8 volts, which is good. As you can see in the dial of the multimeter, the sun has now come out again, the clouds have moved and the voltage has risen straight up through to the 6 volt mark. When it's at 6 volts, the current will be at about 0.45 amps. We're at peak voltage now, I would think, 6.16 to 6.18 volts. That's sort of the highest we've got at this time in the morning. We haven't got long left now before the hour is up, but we're now at 5.9 volts. Starting to drop a little now as the cloud cover comes over again. Getting a little overcast. down back to 5.7.5, and not far away from the 7:45 mark, which means that the test will be running for about an hour. I think this is fairly good results without any voltage regulation. This is simply from the photovoltaics. Ideal, really. It means that hopefully the power bank will have powered it overnight, and it can start trickle charging again early morning and for the rest of the day, in preparation for another night of darkness, and hopefully that cycle will continue. So just to sum up the results that we saw today from the test that was on the 1st of July 2018, which was a Sunday morning in the summer in northeast England. We had at about 7:45 we had a voltage of 5.36 volts, and it increased steadily over that time, rising, peaking and having troughs, but certainly not going back down below the 5.5 volts again, which means that from around 6:45 every summer morning we should be charging the power bank successfully. We hit a high of in that hour of about 6.18 volts, which is around 0.45 amps that we're generating at that time, and we had a low of 5.36 volts. But more or less in the middle, we're getting 0.2 to 0.3 amps, which is ideal. And indeed, we could run it directly. We could run the Raspberry Pi directly off the solar panel without any battery source in the middle, using that sort of current and voltage. And that's it. That there proves that we can, at least theoretically, charge the power bank from a solar panel, or two solar panels. Two extraordinarily expensive and inefficient solar panels, as it turns out, but I did say that I was going to be full of ineptitude. So, next episode, we'll be starting to work on the sensors on the Raspberry Pi and possibly a bit of the code. So, thank you for watching. I hope you've enjoyed it. And if you have, like and subscribe and click the little dingy bell thing, because that's how YouTube works. And I'll see you hopefully next time. Thank you for watching.